Hi, in this video I'll be going over some MATLAB basics, nothing too advanced, but just enough to get started with analyzing Raman spectra. Now when you first open up MATLAB, it'll probably look something like this. At the top there are a bunch of buttons. On the left is your current folder that MATLAB is looking in. So in my case, it's looking under the MATLAB folder in my Documents folder. And in this area you'll see all the contents of that folder. On the right is the workspace, and this is where MATLAB keeps track of all the variables you've created. So for example, it'll say their names and their values. In the middle is the command window, and in here we can execute lines of code one by one. Now 99% of the time in MATLAB you're going to be working with some kind of matrix. So let's try making some matrices. Now matrices in MATLAB are enclosed by square brackets, and in between the two square brackets you enter the values of all the elements. Now elements along the same row are separated by spaces or commas. So for example, we can have 2, 7, 9, 4, 5, and MATLAB will interpret all of these numbers as being along the same row. When we want to complete the row, we just add a semicolon and we can start adding more numbers. Now these other numbers over here are going to be interpreted as being on the second row of the matrix. For now, let's try creating a matrix with a single row containing the numbers 1, 2, 3, and press enter. So you'll notice two things happen. First of all, in the command window, we get this output showing us what matrix we just created and what variable it was stored in. Now, we didn't specify any variable to store this matrix in, so MATLAB always creates this ANS variable, short for answer, in case you ever do that. Now you'll see in the workspace it was also updated. We can see this new variable called ANS, and we can see the value of the variable. Now let's try assigning the same matrix to a variable called x and suppressing the output. So what I'm going to do is I'm going to say x is equal to, and I'm going to type out the matrix again. This time I'm going to add a semicolon to the end of the line of code in order to suppress the output. So when I press enter, you'll see we don't get the same output as we did before, but we did create a new variable called x because our our workspace was updated, and we can see this x variable now exists with the value of this matrix 1, 2, 3. Now we can make another matrix y, and let's give it 2 rows and 3 columns. So I'm going to start entering numbers here, 4, 5, 6, add a semicolon to indicate the end of the row, and continue adding some numbers, 7, 8, 9, close the matrix with a square bracket, and suppress the output with the semicolon. You'll see our workspace was updated again. We have this new variable called y, and this is the matrix. If we want to see visually what that matrix looks like, we could just type in y in our command window, hit enter, and it'll show us that matrix. So we have 2 rows, 3 columns, the numbers 4, 5, 6 in the first row, and the numbers 7, 8, 9 in the second row. Say we want to combine x and y into the same matrix. Essentially, I want to stack the x matrix, which looks like this, on top of the y matrix. Now, how do we do that? I'm going to create a new variable here called z. I'm going to set it equal to, open the matrix bracket, enter the first matrix x, and the row, and enter y. So what that's going to do is it's going to basically put x in the first row, start a new row, and then put y below that. So when I hit enter, you'll see what that looks like. We have this new variable called z, and essentially what we've got here is the x matrix up top and the y matrix beneath that. So a lot of times you'll want to be retrieving certain values from certain elements in the matrix. To do that, all you have to do is type in the name of the matrix. So in this case, I'll take the matrix Z and use round brackets here. And inside the round brackets, you just have to specify which row and which column you're trying to get the value from. So for example, let's say we're trying to retrieve this 7 right here from the Z matrix. Well, we know that this 7 is in the 3rd row, 1st column. So first you type in the row number, which is 3, and then put a comma. And then in the second entry, put the number of the column, so column 1. When we hit enter, we see that the answer is 7, and that's exactly what we expect because 7 is in the third row, first column of the Z matrix. What if we don't want to get just a single entry, but we want to get, let's say we want to retrieve the 7 and 8 here. Well, we can specify a range of values using a colon. So to do that, we just type in Z again. We still want the third row, but for the columns, I'm going to choose the first, a range of numbers from the first to the second column. If I hit enter, you'll see that we got 7 and 8. And this makes sense because 7 and 8 are in the third row. That's why we have the 3 here. And they're also in the range of the first to the second columns. That's why we have this like 1 to 2 here. Another thing you can do if you want to get all the columns is to just enter a colon instead of putting any numbers in the column section of this input. So for example, Z, open bracket, row 2, and then enter a colon for the column entry right here. What that's going to do is retrieve all the columns in the second row. So hit enter, see we get answer is 4, 5, 6, and that's what we expect because the second column looks just like that. Now there are also plenty of useful functions. So for example, if we type in mean y, what that's going to do is it's going to go to our y matrix here, and it's going to create a row matrix where each entry is the mean of every column in y. So let's just hit enter to see what happens. We get that the answer is 5.5, 6.5, and 7.5. Where did we get these numbers? Well, 5.5 is the mean of 4 and 7. 6.5 is the mean of 5 and 8. And 7.5 is the mean of 6 and 9. Another useful function is the size function. It basically tells you how many rows and columns you have in your matrix. So if we type in size y, we get 2, 3. So the first number here indicates the number of rows, and the second number indicates the number of columns. So if we go back to our y matrix, we'll see that we have 2 rows and 3 columns. So that's why we're seeing 2 in the first entry and 3 in the second entry. You can also perform math operations on your matrices. So for example, to add 3 to every entry in a matrix, just type in the matrix name plus 3. So let's take our Z matrix, which remember looks like this. And then if I type Z plus 3, you'll see that it took our Z matrix and added 3 to every entry. So 1 plus 3 gives us 4, 2 plus 3 gives us 5, and so on. Note that we're not actually affecting the value of our Z variable here because we didn't tell MATLAB to assign this matrix here to any variable. So if we type in Z again, it still looks like the original Z matrix that we created. So you can also do the same thing with subtraction, multiplication, division. So Z minus 2, for example, Z times 5, and Z divided by 2. You can also do matrix multiplication, but you just have to be careful to make sure that the dimensions of the matrices are compatible. So remember that the inner dimensions must match, or in other words, the number of columns of the first matrix must match the number of rows in the second matrix. So for example, if we try multiplying this matrix, 1, 2, 3, so that's a single row, 3 columns. We want to multiply that with another matrix, that's a single row and 3 columns. We get an error, and that's because we have the incorrect dimensions for matrix multiplication. We have 3 columns here and 1 row here. What we want is the number of columns in this matrix to match the number of rows in this matrix. So in order to fix that, we can take that 1, 2, 3 matrix and multiply it by a matrix with 3 rows and 1 column. So 1, 2, 3. So this matrix right here that I just created has 3 rows because I indicated the end of a row here and the end of a row here. And it has 1 column. So when I hit enter, we actually get an answer this time because the dimensions were compatible. Another thing you can do is perform element-wise multiplication. To do that, you just add a period right before the division or multiplication sign. And now all that does is it multiplies the matrices by multiplying corresponding elements. So for example, if we have 1, 2, 3, period star 2, 3, 4. What this is going to do is it's not going to perform traditional matrix multiplication, but what it's going to do is it's going to go to each corresponding element and multiply them from between each matrix. So for example, it'll take 1 and multiply by 2. That'll be the first entry. The second entry is going to be 2 times 3. And the third entry is going to be 3 times 4. So even though the dimensions aren't compatible for regular matrix multiplication, it will work in this case because we're multiplying element-wise. When I hit enter, you get this matrix 2, 6, 12, which makes sense because 1 times 2 is 2. 2 times 3 is 6, and 3 times 4 is 12. Now I'm going to show you how to plot some data. First, I'll introduce the editor. So to bring out the editor, we have to press on this new script button right here. And it brings up the editor. Now in the editor, you can write as many lines of code as you want without having to run them one by one. Once you have all your code written down, all you need to do is hit run right here. So say you have some data that looks like this. X is our independent variable. So we have 1, 2, 3, 4, 5. And then Y is our dependent variable. And let's say, for example, we've taken 2 trial measurements of Y for all of these independent variable values. So Y1, we get 3.4, 6.7, 8.3, 12.1, and 16.4. And for our second trial measurement of Y, which I called Y2, we got 4.4, 4.9, 7.2, 9.8, and 14.4. So what I'm going to do to plot these out is, let me just do that so you could see what I'm doing here. So I'm going to make an X matrix here. I'll call it X. And I'll say it's equal to this row matrix with values 1, 2, 3, 4, 5. I'll suppress the output by putting the semicolon. I'll make another matrix called Y1 for our first trial measurement of Y. And I'll input the values 3.4, 6.7, 8.3, 12.1, and 16.4. And then same thing with Y2. I'll put 4.4, 4.9, 7.2, 9.8, and 14.4. So now we have our 3 matrices that have all of our data in them. To plot the data, all we have to do is type plot, put our independent variable first, so that's X, and then put the Y values. So in this case, I want to plot the first trial Y measurements, so I'll put Y1, close the bracket, and press run. So note that whenever you're using the editor, you can't just run code as you do in the command window. You have to actually save your script somewhere. So in my case, I'll just save it in the same location that MATLAB is currently looking in. Just press save, and it will create this figure. So that's what that looks like. On the x-axis, we have our independent variable y, and on the y-axis, we have our y1 measurements. So for example, this point here, if we hover over, we'll see that the x value is 1 and the y value is 3.4, which makes sense according to what we've got down here. And then our next point is x equals 2, y equals 6.7. Again, 6.7 comes from here, and so on. If we want to plot our second trial, we just replace the y1 with y2, hit run, and you'll see that our figure here updated. So now we're looking at the second trial y measurements. Now what if we want to plot both y1 and y2 on the same graph at the same time? What we can do is plot x, y1, hit run, but you'll notice that nothing happened. And the reason for this is because we haven't told MATLAB to hold on. So we have to tell MATLAB to hold on, and essentially what it'll do is it'll plot this first, the first measurements first, and then it'll plot y2 on top of the current graph. So normally if you were to not include the hold on, it would plot this first and then erase whatever is on the plot and plot that next. We don't want that to happen, so we include this hold on line here. If I press run, you'll see that we now have both graphs on the same plot. The blue line corresponds with the first line of code here we did for plotting, and the orange line corresponds with our second y measurements. Now, another way to plot both lines at once would be to have both sets of data in the same matrix. So what we can do is we can create another matrix called y, and what I'll do is I'll stack them on top of each other. So y1 will be on top, I'll end the row and add y2 on bottom. And then I'll just get rid of all this. I'll run the code. So what's happened is we've created a new matrix called y here. And basically, if we look at what that looks like, just type in y in the command window, we'll see that we have the first matrix on top and the second matrix on bottom. So what happens when we type plot x against y? Well, I'll close this figure, hit run, and another figure is created that looks exactly the same as what we were just looking at. So essentially what it did is it went through the matrix y, looked at the first row and plotted all of those against x. And then once it was done with that, it went to the second row and plotted all of those against x as well. If you had 50 different rows in this y matrix, then it would plot each and every single row against x. And that's about all I wanted to show for MATLAB Basics. In the next video, we'll be looking at how we can apply all this to actually analyzing Raman spectra.